Welcome to the lesson on AI agents. In this lesson, you will explore what AI agents are and how they work. Next, you will learn the functionality of AI agents. Additionally, you will learn the types of AI agents available. AI agents are autonomous or semi-autonomous software programs designed to perceive their environment, process information, and take actions to achieve specific objectives. Think of them as autonomous assistants that can sense, think, and respond. They process inputs, often using machine learning or rules-based logic, to decide the best course of action and then act accordingly. Now, let's learn how agentic AI systems work. The agent's journey begins with perception, the stage where it gathers input. There are several types of inputs an agentic AI system can receive, such as sensor data, voice commands, and direct user interactions. However, in most AI systems in the tech world today, the journey typically starts with natural language input. Whether it's a typed question, a spoken request, or a conversational context, natural language serves as the primary way users communicate goals and intent to the agent. Through natural language processing, NLP, the agent can interpret commands, queries, or observations expressed in human language. It breaks down sentences into meaningful components, extracts entities, determines intent, and understands the semantics of the input. For instance, if a user asks, "Show me the top-performing products last quarter," NLP allows the agent to identify top-performing products and last quarter as key elements, preparing it for deeper analysis. Once the input is understood, the agent enters the reasoning phase, where it starts making sense of what it has perceived. This is the cognitive core of the agent, where it interprets the user's intent, evaluates context, considers constraints, and decides what to do next. The reasoning process is powered by large language models or LLMs, which provide the agent with the ability to reason through natural language, infer meaning, and plan actions. The action phase is where the agent executes a decision. These actions could involve querying a database, generating a chart, sending a message, or even calling other tools or APIs. For example, when a user asks, "Why did the growth of the jacket's product type slow down in the last quarter?" The agent doesn't just fetch data. It analyzes trends, compares performance across time periods, identifies contributing factors like declining sales in specific regions or reduced marketing activity, and then constructs an explanation. The explanation can be in the form of text or visualization. Lastly, let's move on to the memory and learning phase. Intelligent agents improve over time through the memory and learning phase. This phase enables the agent to store knowledge from prior interactions, user preferences, and outcomes. With this contextual memory, the agent becomes increasingly helpful and efficient. For example, if a user frequently asks about regional sales trends, the agent may proactively suggest related queries or prioritize that data in future responses. Advanced techniques like reinforcement learning, vector memory storage, and feedback loops empower agentic systems to evolve, adapt, and deliver a personalized user experience. Together, these components enable the agent not just to act, but to adapt, learn, and evolve in dynamic environments, continuously improving its performance and delivering increasingly personalized and intelligent assistance. Lastly, let's learn the types of AI agents. To start with, we have simple reflex agents. These agents operate on a set of predefined rules and respond directly to specific inputs. They do not maintain any internal state or memory of past actions. Next, we have model-based agents. These agents maintain an internal representation or model of the world. This allows them to make decisions based not only on current input, but also on their understanding of the environment and past interactions. Moving on, we have goal-based agents. These agents are designed to achieve specific objectives. They evaluate possible actions based on how well those actions move them toward their goals. Next, we have utility-based agents. These agents go a step further by not only pursuing goals, but also evaluating the desirability or utility of different outcomes. Finally, we have learning agents. These agents hold the same capabilities as the other agent types, but are unique in their ability to learn. New experiences are added to their initial knowledge base, which occurs autonomously. For example, Spotter is primarily a learning agent with strong model-based and goal-based characteristics, designed to adapt, reason, and autonomously assist users in analytics and decision-making. To understand more about Spotter's agentic capabilities, refer to the Using Spotter Agent lesson in the Spotter course, available within this learning path.